All right, thanks for coming out. It's very early in the morning. I was yawning all the way in here, but all right. So when the two of us were kids, we loved space. We loved NASA. I mean, anybody here want to work in mission control or be an astronaut, anything like that? Yeah, right. I mean,
Yeah, me too. At least if I couldn't be an astronaut. The launch status check is so cool, like Capcom Go, TBS Go, And when I built my first NOC, I emulated that design, but I think we've moved past that.
If you need a monitor to tell you something is wrong, then your alerts are not configured correctly.
Service outages or imminent service outages, broadly deprecate, reduced capacity, etc., should produce alerts that page an SRE.
Right, and lower grade problems that can't be resolved by an automated response should create a ticket that's tracked in your ticket system.
Anything else should go in your system log. It should not go to your inbox. Your inbox, your mail, should be full of high-value, actionable information like meeting invites and reminders to update your 401k preferences.
Which I miss every year anyway, right?
Yeah, preferably created by your colleagues and not some automated system sending you spam.
So alerting on any single component that has lower reliability than the service that it provides is, wrong. Capital W, wrong.
At worst, you should, worry about reaching a threshold where too large of a portion of your components are down. And even then, you probably want some sort of velocity metric added to it.
Yeah, exactly. I mean, creating a ticket in a queue that gets someone to eventually fix a failed component is fine, but putting something in the alert pipeline so that it interrupts isn't.
The first alerts that you want to create should be user experience driven. Are your users having a problem using your service? What is your error rate? What is your latency?
Right. Host alerts are worse than no alerts. I mean, you still don't know if your service is working, right?
And you still have to rely upon users to tell you if you have a problem or not.
Yeah, but now you're sleep deprived, like I was this morning. Either any proactive work that you're trying to undertake is constantly interrupted by responding to and documenting your response to alerts for non-user impacting events. Or you've given in to alert fatigue and you're not investigating the majority of your pager events, so why are you paging yourself in the first place?
So what makes a good alert as opposed to like a metric?
Well, it needs to be actionable to start with, right?
Yeah, for Christ's sake, if you get an alert, you should be able to do something about it. If not, you're just burning out your engineers.
So it sucks if an alert goes off for something and it's only actionable some of the time, right? If 9 times out of 10 a human wakes up, investigates, and then determines it's not a real issue, eventually everyone just stops responding to the alert.
Yeah, it's almost worse than having no alert at all.
Yeah, I mean, the most common case I've seen with this is where teams kind of run afoul of their noise floor, right? Where you say you have a time series or a log feed that's across a broad spectrum of traffic with hundreds of thousands of data points. And the amount of cruft and false positives isn't even noticeable, right? But then when you have a slow period, or you need to look at just a portion of your traffic, like just playback of VP9 encoded streams, just for premium content, just on Samsung TVs, running only the previous client version for just a single service provider who happens to be Netflix. That noise floor is larger percentage of your traffic, of your actual signal, and suddenly, you're getting pager events that may or may not get ignored.
Yeah, and some teams will just accept that and either alert anyway or never alert below a certain threshold, and neither of those responses are really appropriate. We've had good results from adding trending or velocity components to those kind of metrics, or by writing tools that classify and group log events that using lots of data points, and it works pretty well. You can fix this problem, and you don't have to live with it, so don't let people tell you otherwise.
Yeah, I mean, this isn't just a burnout or response fatigue problem, right? Relying significantly on the ability of humans to parse and either consciously or subconsciously recognize patterns in your data or absorb a vast corpus of tribal knowledge around what is or isn't an important alert dramatically slows down your time to on-call effectiveness for new hires and for team transfers.
Even if you're the mistaken believer that human intuition will be able to pick out the potential problems that you couldn't more easily build programmatic detection to call out, it takes so long to get there, especially for a live system that should be changing and evolving. Your overall effectiveness over the course of 2 years is going to be much lower than if you can be relentlessly going after and fixing those issues. You should never alert on anything that you can fix without a human being. If automated remediation is possible, you should at least try that first and then page only if that fails.
Right. You really want to do everything you can to avoid SRE burnout, right? How many alerts do you think can fire in an on-call period before an SRE is going to stop being effective?
I know the third time that I get alerted in the middle of the night, like woken up, I just want to go back to bed, right? So, and honestly, that's like a whole nother thing. When alerts fire in the middle of the night, gather the ephemeral data about the system, do the minimum you can to stabilize the service to the point where you're confident the problem isn't going to come back, and then go back to sleep. Like, don't expect SREs to root cause every minor production issue in the middle of the night.
Yeah, I mean, as long as you're stable, that will wait till the next business opportunity, right? SREs should only be spending 50% of their time at most working reactive issues. This means you need to be able to have enough people in your on-call rotation so that we don't exceed that. If the service is too unreliable or your team is too small to support that, you need to find out a way to get product developers into the rotation until the service is more stable and or the SRE team can grow. And a lot of companies run that way all the time and do very well with it.
Yeah. SRE should spend half their time making systems better or building new ones as opposed to troubleshooting or fixing the existing ones. For that to be possible, you can't spend more than 25%, 1/4 of your time actually on call. For most teams, that means you need 8 people for an on-call rotation. With a primary and secondary rotation, that works out to about 1 on-call week per month.
Right. And the idea here is your team is, you're not just rebranded ops, right? Your alerts should tell you when you're having problems, not your customers, and not a group of people in a NOC carefully watching, little blinky traffic graphs.
I don't even think you need a NOC anymore.
Well, I mean, right. And this is basically how this talk started, right? I mean, I don't either. Though to be clear, when we say you don't need a NOC, we're not saying there's no use for like a war room, and if and when such a thing is warranted for an incident response, right? Even there, though, the important thing is that your tools should be constructed in such a way that they can be used for collaboration without being tied to physical location.
War rooms are basically a response to old tools and structures that we've moved past.
How much better is it to have like n pairs of eyes looking at stuff on 2n pairs of monitors, and then rather than have a room with just like n screens and just a handful of people who can control what's up there?
Having to have everyone who wants to discuss something have to put it up on like one shared monitor where other folks can't poke at it, like you do in a NOC or a conference room, isn't as good. More brains and hands able to manipulate information directly while still preserving collaboration and sharing is much better.
Right. If you want to share a link to a particular time series, you should be able to post it in a chat or something like that, right, such that everybody can look and see the same plot with the same filters for traffic, start, end time, resolution, all that sort of stuff.
Yeah, preferably with actual live data and not just a screenshot, so other folks can take that as a starting point and find their own explanations for what's going on with your system.
Yeah, and if the data is ephemeral, I mean that data should be preservable, right, with some sort of a checkbox or a flag type operation, so that you can actually make it available later and see those same views for a postmortem.
Similarly, the point people make about we want instant response and communication between responders, so we need a NOC, can be overcome by pointing out that none of this means you shouldn't have a designated on-call for every aspect of your service or your operation.
Yeah, but those folks should be able to do everything from their laptop, preferably from anywhere.
Yeah, I've responded to pages from some of the most absurd places. I remember troubleshooting a site while sitting at a bus stop in downtown Oakland once. What's the weirdest place you've responded to an incident from?
I don't know. I did one in a Denver airport at the gate to the plane.
I am so glad that so many places have free Wi-Fi now. I had to troubleshoot a site from a McDonald's in South Central LA.
You didn't tell me the central part before. You just told me it was South LA. Oh God, I'm glad you're still with us. Okay. Yeah. Let's see. I don't know. I did a parked car in the middle of a Christmas parade outside of a shopping center.
Speaking of airports and Wi-Fi, and a perfect example of why you need a really good secondary rotation, I once had to decide if I should get off a plane that I had just boarded because my pager went off and the secondary was on the same flight with me.
Who designed that rotation?
I'm pretty sure it was my manager, but it could have been me.
Okay, yeah, blame the manager. Excellent.
We ended up troubleshooting the problem using the in-flight satellite-based Wi-Fi, and let me tell you, SSH is amazing with 600 round-trip time latency.
Okay, you want latency. sitting in a traffic island in the middle of an intersection in West Seattle via cell phone in the middle of a storm at 2 a.m. because it was the closest place that I could find reception, and we had a problem in Taiwan.
So anyone in the audience got a better story than that?
No? Okay, well, you all have much better jobs than we do then. So, I mean, really, at this point, basically, what we're really proving, I suppose, is that having good secondary on-call rotations can help you. And if you plan them properly, you don't have to worry about knacking before you get on that plane, right? But I would also point out that even like the most outage-sensitive services at Google, never have shorter than like a 5-minute SRE response SLA, meaning that the on-call will be actively working any issue within 5 minutes of the alert. And most have a 30-minute on-call response.
Yeah, unless there are actual lives directly on the line, if you think your potential revenue loss number or number of customers impacted is greater than Google's, then please contact me after this talk, because I want to hear about you and whether or not you're hiring.
And even then, we can make the system work better by ditching the NOC and building scalable, distributed monitoring, alerting, and administration tools, right? So, I mean, going back to like mission control, or better yet, SpaceX, because I'm from Seattle, so SpaceX, yay! But if you go and watch old movies about Apollo missions, you'll see that they were reacting to alarms when they acted, not like just something that showed up on a plot or a number.
Right, they didn't go, hey, something on that graph looks weird. Having everyone in a war room or situation mission control room meant that they all had the same information and they could respond quickly to alarms.
Yeah, and they were also in a situation where actual lives were at stake, and a 5-minute response isn't acceptable.
Yeah, if you watch, there's a YouTube of the SpaceX launch from February of last year, and the rocket had a low thrust alarm go off at T-minus 1 second, after the engines had already been ignited. And the computer aborted the launch. Automatic remediation that no human would have been fast enough to respond to.
No, I could do that.
Well, okay. So you're the one guy, but you need
I would need a lot more caffeine.
It's a really high. It's a really low bus factor.
Okay. I should know better. So another thing is that launches, though, are something that NASA does, maybe a dozen times a year, right? I mean, so getting everyone in the room for launch is understandable. I mean, how many dev teams are there that only want to launch 12 times a year?
Like every dev team I've ever worked with.
Okay, fine. So I've actually known some that only wanted to launch twice a year, but we fixed that, right? We made them do it more frequently. But
fair enough. Netflix had a war room set up when it did its big global launch last January. It makes sense for special events that are high profile, but not for everyday operations. And also echoing that we have a war room that we can use during an incident, but it doesn't mean that we sit there every day. It's just essentially a conference room with some extra TVs in it so that we can get a lot of people in the same room.
Yeah, I mean, the same thing for Google. They build tools so that we can work collaboratively at home, in our cubes, on the road, or in a big conference room, that we keep set aside for use when necessary. But they free us from the tyranny of, fixed views and fixed locations. And so, once we weren't relying on staring at plots looking for, something weird anymore, the big shared displays really just kind of, devolved into a form of reliability theater, right? Where we could show visitors who don't know how reliability and incident response really work, how incredibly serious and deeply technical we were, with blinky lights in full color.
Despite the fact that we're running in the cloud, we might as well have just kept a racks of servers behind a glass wall so that everyone could see how impressive our infrastructure was.
Right. It makes about as much sense, and impresses about the same kinds of people, which we soon decided we didn't need to impress. I mean, that's certainly not the case for everyone by any means, though I wish it was.
Yeah, so you had all these monitors sitting around that you used to use for showing the state of everything. What did you do with them?
Well, at first we thought, we could use them to let people know whether there was an incident response in progress, right? Kind of like the yes, we know we have an outage, please stop calling us banner that you get at the top of some web pages, right?
But we found that putting up this sort of bat signal, blue light alarm, drives another anti-pattern, which is like the mob incident response.
Right, you know how it goes. Something big goes wrong, something important in your system, and an all-hands-on-deck alert goes out, whether through pagers or emails or, a big Star Trek klaxon that, they've gone plaid.
It's satisfying and exciting because yes, when I was a kid, I wanted to be Captain Adama or a NORAD general too. But because everyone else in the team naturally takes an interest, pretty soon your incident response looks like this.
You were a stage manager. That's almost the same thing, right? Which is okay, right? If you're, it's sort of a sprint, it's going to have a quick resolution, or if you happen to be a 5-year-old playing soccer. But sometimes you'll find it drags on, right? Sucking in more and more people, and then you have no one who's fresh to come in and take a second or a third shift, right?
Yeah, it's better to stick with an established, explicit incident management protocol with on-call rotations and have the incident commander or area lead responsible for bringing in the people you need to solve the problem.
Right. So, since that's out, we now just basically use those wall projectors and monitors for atmosphere, right? I mean, it's playing movies, without sound because the walls are thin and the next team over doesn't like it very much. Picture feeds from our offsites, all that sort of thing. The team down the hall has theirs set to a permanent hypnotoad, which is really disturbing when you walk by. But a few others, they use it for bug burn down displays, software projects, things like that.
Yeah, we did an office move a little while back, and we just got rid of all the monitors completely because Netflix has better things to do with TVs.
Okay, well, you're very evolved then. Namaste. But, we're a little more clingy, I guess. I don't know. The important thing is that everyone has reoriented their workflow and their attention model around a system where the computers tell us when something is out of compliance, right? Before our end users notice, with a minimal appropriate number of, responders, that can handle that situation from the tools and the locations that they use to do the rest of their job every single day.
Yeah, so we have a refined paradigm for monitoring our systems and responding to problems, but what exactly are we monitoring?
Well, by now, most of you are probably familiar with the analogy Randy Bias put forth the last couple of years, saying, traditional system administration treats servers as pets.
Right. Traditional infrastructure is expensive and administratively inefficient. People give servers names and lavish attention on them, and when they suffer problems, the admins diagnose them and nurse them back to health by modifying them directly over Serial Console.
In other words, we treat them as part of the family, because I plug Serial Consoles into my family all the time, right? That makes no sense. But early virtualization didn't really change this approach much, right? Whether the servers were physical or virtual, they were long-lived, infrequently rebuilt, and therefore they demanded personal attention and developed emotional attachment. Admins would have ceremonies, joyous or mournful, and like one of their favorite or least favorite charges finally kick the bucket, right?
I clearly remember throwing a server off the 8th floor of a building once.
50 we used to do data destruction with 50 caliber. That was
I've heard of that.
It's recommended practice by the DoD, I think.
Yeah, totally. So snowflakes are bad, no matter what platform they're hosted on, and the effort to maintain them does not scale sublinearly to the deployment.
Ooh, sublinearly.
Hey, it's one of my favorite terms.
Okay, all right. I think little Snowflake up there is hurt that you don't like her, right? I mean, look at her hang her little fluffy head. How can you resist that?
Come on.
No? Okay, all right. Well, Randy's talk also pointed out that the new paradigm was to treat virtualized servers as cattle, right? Cattle have numbers, not names. When your cow breaks a leg or otherwise becomes incapable of staying with the herd, you butcher or render the cow and move on.
The unit of administration for cattle is generally by the herd. Like, you brand all the new cattle at once, you vaccinate them all at once, you breed them and feed them and harvest them in large batches, not on an individual timeline. Some things are still handled individually, but like as little as possible.
Right. I mean, the less time you spend making changes on your servers, and the more you can make their configurations immutable and homogeneous, then the better your cost of administration scales in relation to your workload. The more you can get done, the more reliably you can do it, and the faster and farther you can move.
So then Bernard Golden expanded on this a bit, right, and made the nice comparison that if virtualized servers were cattle, then containers could more properly be thought of as chickens.
Right, or ducks or geese or squab or whatever. Basically, your bird of choice.
Eagles.
No, not eagles.
Not platypus?
Come on, that's not even a bird.
Okay. The point is poultry grow to maturity much faster than cattle. They're more efficient than cattle as opposed to in terms of resource use. You can stack them up in less space. You don't have to cover as much ground to manage them. Similarly, containers launch in seconds rather than minutes, and containers require far fewer compute resources in comparison to virtual machines.
But more than platypus.
More than platypus.
But in spite of that, because they're so cheap, and as a result, so numerous, you can manage them in ways that even a cattle rancher wouldn't dream of, right? In fact, you have to. They're designed to be immutable from the very beginning, meaning wherever you want to make a change, you don't modify a running instance. You just shoot it in the head and push a new one.
Yeah, and from what I understand, in like Japan and Denmark, poultry farmers kill off entire coops if one of the birds is sick. We can kill off entire clusters because of immutable infrastructure. Combined with container efficiency and programmatic configuration management, it makes it so easy to spin up new ones as long as you're willing to adopt and stick by an iron rule, which is no more snowflakes. No more snowflakes.
Yeah, right. I mean, I just feel like we should point out, though, that we're not talking about any sort of we've got this policy, right, and non-harassment. But we're not talking about any sort of liberal, millennial, insert your outraged or offended stereotype here joke, right? This is purely Snowflake servers, right? Servers that are unique, require special handling, especially any manual handling. It's more common these days to, accept that every change you make should run through version control and configuration management. But of course, that actually isn't enough.
You don't get far using configuration management tools like Puppet and Chef as a crutch to administer tons of snowflakes or pushing system updates rather than fresh installs.
Right. It's better to get your fleet standardized on as few platforms as possible, running idempotent pushes of a hermetic build and config pairings.
I've heard people talking about Chef configs with hundreds of configs just to manage thousands of servers.
Yeah, that's suboptimal, right? Hiring a dog walker, to tend all your pets is great, but it isn't the same as trading them in for chickens.
No, configuration management is actually a huge trap.
Yeah, it promises to deliver standardization and automation, but in reality, it ends up enabling the old broken paradigm to be replicated at kind of a mid-sized scale.
Instead, use the benefits offered by configuration management to convert your systems to immutable infrastructure. If you're running on a cloud, this means baking your machine image with your application code already on it, or an immutable container image that gets hosted on an immutable system image.
Right. Start with a well-configured base image, and then add the application code, to your image, right?
Yeah. And even if you're not running on a cloud, you can do this on bare metal infrastructure with containers.
So configuration management also doesn't scale, organizationally. You have more important priorities than to teach every, product developer in your company Puppet DSL, let alone, have them learn to know it well.
Yeah, configuration management will not allow you to grow your operations to large scale. Or to scale them non-linearly with staff, as you can by going to immutable, interchangeable systems with an infrastructure that's not just automated, but autonomous as possible.
Right. So people push automation a lot, and automation is good and necessary, right? It's not as good though as a system which doesn't need automation, which is much harder, but and not something people really talk about.
There's typically several stages of development in an automated or autonomous system.
Yes, we administer a bunch of things. All the things. And then admins, write scripts and some tools to handle some tasks that they perform repeatedly, and then they run them as necessary from their laptop or some, management workstation. And that, that's working pretty good, but it's annoying. So, the tools are scheduled and, set with triggers to run without user input.
Then those successful tools are centralized and shared with version control and everything.
Right, and then, hey, those centralized tools, they're pretty useful. So they get generalized beyond the specific systems and operations that they were initially created to automate.
Right, and then admins write scripts to tune or extend those centralized tools for specific new systems and run them from their laptops and management bastions. I think we've just come in a great big circle.
Yeah, well, automation in this manner, right, by scripting operations that would otherwise be carried out manually without addressing the underlying architecture that necessitates the intervention, requires significant ongoing investment as the platforms and services change.
It's fragile and is prone to decay and cruft. If the team is not obsessive about keeping the automation in step with production, it will break.
Yeah, and when it breaks, your responders will find that they can't easily perform the old manual processes anymore. It delays your resolutions.
Yeah, we've all seen things like this, right? The automation script doesn't adopt a new flag that you need, and it ends up breaking more of production rather than fixing it in the middle of a crisis.
Amazon.
Hey, don't pick on S3.
So the answer, I'm from Seattle, I'm allowed.
Okay, fair enough.
The answer is to design systems that wherever possible, don't require intervention.
It's good and useful to script a MySQL database failover that admins need to execute occasionally, but it's better to have the service detect when the database needs a failover and do it automatically.
Yeah, but best of all is to determine if there's a way to meet the service need without running a relational database, to record and replicate data without a global write master or something like that, right? So that your data layer becomes a legion of unimportant, globally distributed instances that you can replace in moments whenever needed.
This is a process and a mindset that needs to be integrated from the earliest stages of development and design.
Yeah, and retrofitting for this is possible, but it involves a lot more pain because every component at every stage along the way needs to be created with the idea that nothing is reliable and any particular thing might disappear at any point in the life cycle of a service or a host or an instance or a request or an admin or your speaking partner.
Right. You going anywhere? Some automation can be good. For example, if you have a remediation job that's triggered anytime one of the Cassandra nodes fails. It's triggered by your alerting system, and it repairs the Cassandra ring without any user intervention. In this case, it's a repair mechanism that allows you to adopt a resilient database.
Yeah, absolutely. Don't be afraid to automate the repair of a broken system. Don't inflict pain on your pager rotation just because you don't trust yourself to come back and fix the underlying bug.
I've seen this a lot, and it drives me nuts. Instead of nobody wants to tell Nagios to restart Apache because they're afraid that if they implement that as a fix, it'll become new tech debt. And instead of creating that tech debt, they just burn out their entire production rotation.
Right, and instead of doing that, implement the temporary fix and then file a bug to get the underlying issue fixed. Nobody is helped by having a burned out team. And a burned out team is never going to get around to tracking and tackling the bug backlog.
Right. So now that you've built your fancy autonomous system, how do you handle feature releases?
Right. So by now, pretty much everyone should have bought into continuous integration, testing, and deployment, at least in principle, right?
Yeah, and rollback.
Yeah. Well, it doesn't work without good rollback. But the initial investment is not as high as people fear, and the benefit in terms of error reduction, minimization of bad push impacts, and time to recovery are significant. It goes back to having your computers make decisions instead of your engineers when you're dealing directly with large data sets, right? Automating the canary and rollback of new builds can give you a huge availability win.
Yeah, and I have no idea if this story is actually true, but I heard it, and I think it's a really cool idea. I heard that Amazon.com has automated their rollback with their business metrics. So if the billions of dollars spent per second on their site drops after a release, it just automatically gets rolled back.
I'm going to have to see that on Snopes. But the important thing is that you don't need to have an SRE deciding which features in code are allowed to be released into production.
Yeah, SREs are really expensive to hire and train, which I'm actually kind of thankful for. But they're a precious, finite resource. And so is the relationship between those SREs and the product teams that they work with.
Right. And while they're not the only paradigm, error budgets are one way of dealing with, enabling product developers to make their own decisions, pushing code to production, and minimizing the necessary consumption of both of those precious resources.
Yeah, and even with that model, there are different levels of engaging with dev teams.
Sure. The most resource intensive is the embedded SRE model, right? It's great for building trust between product development and SRE, or for very complex and important projects. It allows you to get input into system design right from the very beginning. And I still use this for some high-profile services or where the relationship is new. We'll designate an engineer to join the product team as the SRE lead for a project and attend all their design meetings, the scrums, everything else, and even contribute some features to the project, right? Especially if they're doing anything more back-end oriented, like an interface to the user identity management system. And it actually works the other way around too. We'll have developers come sit and do a tour with an SRE team. It's really one of the best ways to build trust and shared knowledge.
Which both boosts the product team's capacity and ensures the engineer gets to spend some time coding. I've actually heard that Facebook takes this a step further, and those product teams are the production engineer's primary work group with sort of a dotted line back to the PE org.
Right. In a perfect world of unlimited resources, that's probably how we'd run everything, right? But very quickly, we get to a point where this doesn't scale sublinearly with the size of the org or the number of services either.
So the next thing we end up moving to is a consulting model, typically some sort of combination of office hours, project-specific consulting appointments, and what we call a production-ready checklist.
Right.
This is where you got your service written and deployed, for some definition of working, and you want to launch. So you have a bunch of meetings and checklists to make sure that it'll scale from like 10,000 users to 10 million users and not drive whoever's holding the pager to distraction.
Right, and this does a great job of leveraging institutional knowledge of common pitfalls and best practices across many product development teams, but it's still pretty resource intensive, both for SRE and the product team, right? Especially because it often means that some portions of the system work are going to have to be redone, right? Like totally replacing all the monitoring configurations that were used during testing and development with ones that are compatible with existing production services.
Yeah, also product teams can run up to with a release date that weren't planned during with an understanding of the time required to run through the checklist and get to launch readiness, which happens more often than you might think. And while the checklist does a decent job of keeping the same mistakes from being made over and over again, it doesn't do anything to improve the amount of work needed to update old services that went through an earlier version of the checklist and didn't implement the improvements that were made to the checklist after they launched.
Sure. So there's a degree of periodic revisitation and outreach that has to occur to incorporate lessons learned.
Fundamentally, even this model doesn't allow us to touch everything that we need to with reliability engineering or interface with all the projects or teams within our area of responsibility.
Right. So that's why, as time has gone by, we've made a big push into offering development frameworks, right, that can be adopted by product teams without a great deal of SRE involvement, right? Smaller to mid-sized projects especially can benefit, where we wouldn't be able to offer them support early on. But if a product team implements these documented frameworks, they can take advantage of a lot of built-in integrations.
Shared frameworks and templated configurations create a paved road that reduces duplicative work and speeds up review. For instance, the load balancers start up configured correctly. Apache and Tomcat are already properly tuned, and multi-region deployment is automatic, etc.
Right. Using frameworks, dev teams get quick wins for small services, and we can help improve their velocity, their ability to scale, and their availability, even if they never actually engage an SRE team, and SRE will never end up responsible for the pager for their service. Speaking of availability, how many nines do you think is the right number of nines?
I want all of the nines, all of them, please.
So n+1 nines then?
I want n plus n nines.
Okay, yeah, and this is actually, I still run into people, and this is a problem that's endemic in security, which I deal with a lot as well, who feel any amount of effort to avoid any possible failure is justified, right? Any downtime is failure. So I tell them, you probably do this too, some of you, but that's fine. If you want 100% uptime, the first thing we'll do is we'll stop doing any feature releases, right? So, if you want to get n plus n nines, how about n minus n features?
Oh, man. Did you know that 9 nines is 31.5 milliseconds of downtime a year?
How do you even measure that, right? I mean, if your system is down but nobody notices it actually down, or you're just a high-frequency trader, right? The machines notice, I guess, and the billionaires.
Probably better not to disappoint either one of those.
No, probably not. I, for one, welcome our new mega-rich robot overlords.
I think instead of focusing on nines, how about we begin by discussing risk versus reward?
Okay. So here's where we come to a place where we can actually make a business decision about how much downtime we can really tolerate, at which point we have a concrete goal we can try to achieve.
Yeah, and the only way to do that is to figure out first what your service does, and then what data points can reliably measure whether or not it's doing those things.
Your SLIs.
Okay, Google. From there, you can talk about what aspects your customers will see if you're operating at a particular target values for those measures.
Be careful with that OK Google business, okay? I mean, that's like shouting Alexa. I mean, hey, seriously. No, okay. Sorry, we were up really late coming up with these jokes. These are the jokes, people. You either laugh or you don't, but you're going to get them anyway.
Dad jokes for the rest of the talk.
So, once you find a set of impacts you're willing to accept and that don't require a level of infrastructure you're not willing or able to create and support, those target values are now your SLOs, right? Your service level objectives. And SLOs are, they're great, right? They're the best method we've found for reasoning about performance of a service.
But it's understanding the impacts to which they serve as markers that will tell you the relative importance of each of these metrics and help you decide whether to serve degraded results that perhaps only meet some of your criteria or to fail a request entirely and come to an agreement with your service customers and owners on all of this. You can't let the machines decide.
Yet. Remember? Like robot overlords? Choose your side, man. Come on. I fight for the users.
Okay, yet. But the linkage inherent in this process is critical. You don't just want to stick a monitor on your service and then pick the 99th percent values for the past month and then set those as your fancy SLOs. And you don't want to build an infrastructure that will radically exceed your targets either. This isn't even always a cost of waste.
Right, yeah. I once worked on a system where in the course of re-architecting the service to migrate away from a MySQL-based backend to a key-value data store, we reduced the amount of maintenance and downtime required for the system by an order of magnitude, right? And this was, in and of itself, a good thing, and worthy of much celebration, both for ourselves and our customers. But, we made a classic blunder.
I think I heard about this one.
What, never go up against a Sicilian when death is on the line?
No, something about a land war in Asia.
No, I think it was the other one, though. I mean, we improved the system without considering the revisions needed to our SLAs, right? Because all those things are not just parallel, they're unavoidably coupled. And we were not the only people to make this mistake, not even at Google, right? Basically, we kept barreling along, operating under our old SLO and SLA assumptions, right? While our customers quietly came to consider our delivered level of reliability to be the actual level. And as a result, we lost our understanding of the actual customer impacts that would arise from subjecting dependent services to the error budget defined by our SLOs.
Yeah, an error budget is not there to be squandered, but from what I understand, there's no compound interest on anything you save either. You don't get brownie points or quarterly bonuses for not taking the appropriate risks to improve the system.
Right. Inevitably, the next time we went to make major updates to that service and incurred planned disruptions, within the scope of our SLOs, we ran smack into, a bunch of upset and bewildered users who had based their own SLOs off of observed behavior from their systems and ours, rather than the kind of reasoned, deliberate process that we'd engaged in originally.
Not to be all not blameless here, but whose fault was this?
Okay, ours for building a system that exceeded SLOs? Yeah, fine. Guilty as charged, right? But theirs for creating their own SLOs based on observed history rather than our explicit SLA. I mean, absolutely, nobody wins.
This is basically the whole justification for Chaos Monkey. You create an environment where chaos is always there and services are subject to induced failures. This forces product teams to contend with infrastructure that is deliberately unstable.
Right, and Google has moved to doing sort of the same thing with what we call Dust, which is kind of like a mini version of Dirt. It runs more constantly.
Yeah, there's a curve on which you can put your application. There's a trade-off between the speed of innovation and availability. And you might be able to shift that curve by spending more money, but the resources are always going to be limited somewhere. There's only so many SREs you can hire. There's only so many data centers that you can build. You have to start thinking about the trade-offs between cost, features, and reliability. How much does being down for 50 minutes a year really cost you? Because that's the difference between 4 and 5 nines, right? Is that worth the cost of development to get there?
Right, or the limitations that it puts on your product team.
Like somewhere along the line, 5 nines became the gold standard, and everyone has been cargo culting that nonsense since then. You have to pick a value that works for your business.
Right, there's something along the lines of good, fast, cheap. Pick 2. That to be determined here. But I don't know. Except in this case, it's like uptime, velocity, efficiency. Pick 1.
Pick 2.
One of these times I'm going to manage to get that past you. But anyway, we'll workshop it over some more beers later.
It's not even just that, though, right? Because spending more money probably means you have more components in your architecture. And the more complex you make your system, the more likely it is to suffer failure. If there's one thing that the king of DevOps, John Allspaw, has taught us, it's that complex systems fail.
Yeah, you have to consider the impact of the outage, right? I don't think the straight numbers tell the story. Is it worse to be down for 50 minutes once a year, or is 10 minutes 5 different times better? It really depends on your business needs, right? if you run the system that high-frequency traders use to buy and sell stock, it might be worth it. But then again, it might only be worth it during the business hours because most of the time the markets are closed. You don't care.
Right. If you're on the other hand, like if you're responsible for a massive multiplayer online game where the users are completely addicted and they're only giving you $20 a month anyway, like 95% uptime is totally cool.
Although you won't get a bonus for doing that. So, but the response I've seen on Twitter might actually suggest otherwise.
Fair.
But I'm going to let that one go because, as usual, while we're a long way from running out of things to say, whether they have value or not, I think we're running out of time to say them in because I, for one, would really like to hear somebody other than us talk.
End of line.
So, this talk started out actually kind of as a conversation at a bar after a conference, very much like this one.
And over time, it became a series of conversations over drinks, emails, and Google Hangouts.
Right. This is not just an excuse to get up here and read parts of the Google SRE book to you. I mean, really, honestly, these are real stories, real ideas that we've seen proposed and advocated for by speakers and teammates and customers who genuinely believed that the proposals were the right thing to do to improve system reliability, right? And we've left out most of the names of those companies and coworkers because these aren't straw men. They really happened, and they just go, what?
And we've tried our best to kind of reenact those conversations, more or less how they happened.
Yeah, it's your grumpy old man version of how to be an SRE, right?
Yes. One of my favorite though, and arguably most useful parts of going to conferences is the conversations like these that happen, in lunch or in the hallway or at a bar.
Right. So, the questions of the talk, can actually be more interesting than the talk itself. I mean, I think we've pretty much done everything that we could to ensure that with this one. But thankfully, I think we've got time for questions. Where are we at? How much do we got? All right. Awesome. Woo!
So we have some time for questions.
We talk fast when we're nervous. Okay.
If you don't mind, just let them know that they should use
Right. Okay, so I think we've got a microphone down here in the middle. If anybody actually wants to ask anything, we're here. It doesn't even have to be about the talk. You can, ask him how the Philippines was, or something you've always wanted to know about Google but were afraid to ask, or.
Right. Like, what is the hardest question you've ever asked in a coding interview? I guess we're done.
Thank you very much for your. Oh yeah, please come on up. Thank you for starting it. It only takes one.
What do you guys think the best way to collaborate with product teams for figuring out diminishing returns for performance versus new features?
Okay. So you were a performance tuning expert at Netflix there for a while, weren't you?
Yeah, I was on the performance team, although I did most of my work on reliability. I think it starts with figuring out what your goals are, right? Like what performance are you shooting for? What reliability levels are you looking for? That's back to that.
Yeah,
how many nines do you want? How many nines make sense for your service? And then working backwards from there to what's actually achievable with the resources that you have available.
Yeah, honestly, I would say that working with you're saying, what's the best way to work with the dev team on that? The product team are really the people that you need to work with on that. Then you have to work with the dev team as well to figure out what's possible and it makes sense within the architecture. But it really, if you're not looking at what your users are going to demand, the people consuming the service are going to demand, then you're just spitballing, right? You're going to throw things at the wall and you may end up with something totally wrong. We had a problem where we were finding that we had folks in Asia that we had a global distribution that only had one local node in Asia because our SLA for latency was actually fairly high for the particular service that was in question. And when we did a failover of that service that involved having to migrate, there was a forced migration to another location because of a data center upgrade in that data center that we were in. So we went to suddenly not having anything in Asia, but we'd done testing to see that we were still within the metrics there. The fact was that the actual end user need that product development had identified wouldn't match up with what the engineering team was telling us. So if you don't talk to those product people who actually talk to the users, you're going to fail. So we did the failover, the latency jumped, and everybody lost their minds.
I forgot about something. About about a year ago at this very conference, you told me that you had earned this badge.
This is completely unrelated.
This
to
is
the
unrelated
story
to
I just
everything,
told.
but so Netflix has a merit badge that you earn when you take down production. And Blake actually managed to take down Netflix when he wasn't even working there. So I figured I would go find one of these merit badges and give it to him, and it's taken me a year to get it to you, and I don't even work at Netflix anymore, but there's your merit badge.
Oh, I'm so happy. I would like to thank the Academy, but I'd mostly like to hear what that guy has to say. Hi, who are you? What's your question?
So my name's Shane Smith,
Woo.
and I work with the DoD, and we're trying to transform how we specify reliability within services now. And we're fighting the school of the classical MTBF and MTTR and availability. So the problem that we see is for most of our new systems, they don't do one thing, right? They are a collection of multiple services,
Monolithic
human
type, yeah.
interaction, and somebody's going to read data, then react to it. Is there some good patterns for determining SLOs for those type of systems?
All right, so it was a little quiet there. Thanks for not killing our ears, but it sounded like you have systems that are like more monolithic rather than a microservice distributed architecture, and they're trying to do multiple things, and you're having trouble setting SLOs for systems that run like it's more of an active processing. They take in data, they do something, and then they make a decision and send something back out.
Right. But the systems may be distributed.
Yeah.
It's just we don't know what we're trying to do this at the beginning of the architecture, right? So we haven't chose a architecture yet. We're trying to set the SLOs.
Okay. So the more you can do, I mean, and this may not be possible. I know this probably sounds like, hey, don't do it that way. But we've had some situations where, for instance, one of our customers was G-Fiber, right? It's very different from typically worked with things like YouTube, Google Play, Netflix, Amazon Video is also a customer. But G-Fiber was very different. It was this like old school cable, environment. And a lot of the people who were there came from that sort of an environment, and they had very different needs. And so we would initially ended up trying to serve both those out of the same system, kind of like what you're talking about. And things that were efficient for them were just completely not for anyone else, and it actually ended up causing a lot of bottlenecks for us. We had batch processing set up for them because they're dealing with these little tiny set-top boxes with almost no processing power, and they wanted to do lots of traffic in a batch rather than getting everything constantly making these calculations and sending them back and forth. So really, we had to fight for like 6 months with them over this, but getting it to the point where you got it as, they wanted to do like 1,000 at once, and we finally got it down to like 50, which was kind of a good compromise. But if you can possibly find a way to split those things out so that you can consider them individually, your traffic types, you want to, as much as possible, be the same. But when they can't, you want to be able to handle them with different systems, right? Because otherwise, it gets really hard to balance when you don't know what you're going to be getting in. Is it going to be a small packet with a little bit of processing, or is it going to be a big packet with like a 10-second back-end latency delay on the database that has to crunch through that stuff, and the MapReduce that has to run on the data? It's a very difficult problem, right? So the more you can atomize these things, the better result you're going to have. I mean, I know you probably can't talk about anything specific about what it is, but the more specific detail, the more maybe I could help you or
Thank you.
give you ideas.
Hi. Do you have any advice on where to start with doing launch checklists?
Sure. Yeah.
So I just spent a lot of time working on checklists, and there's two things that you need in a system to make it reliable to start with. Like if you can get these two things right, like then you can worry about the last 20%. and that is make sure that you have really good monitoring and alerting and response. So that's, make sure you're monitoring the right things that your customers actually are being impacted by, and make sure that you have alerts that go to the right people and a response plan for that. And then the other thing that I think is super important is having really well-defined and well-planned out release procedures. So you should have a release pipeline that's automated, that runs the same way every time. So you release the same code to production, or not the same code to production, but the code production in the same path, and that happens, in a one-many-all with canaries and all that. Get your monitoring set up right, and get your release deployment procedures right, and you will fix 80% of the things that cause production issues. Then you can worry about the other 20%.
Cool, thanks.
So I suspect the answer to this question is develop trust, but how do you manage, if you're capping your SRE time at 50% responding to alerts, how do you manage convincing product teams that they've exceeded their error budgets other than spending 50% of that 50% time tracking what you're doing?
So personally, I would say you don't want to be the one tracking the error budget, right? I mean, that should be automated. You've got monitoring set up that shows here's our availability, here's our latency, here's over the course of the month, right? That's not a conversation. Those are facts, right? And so it becomes readily apparent. The conversation has to happen up front, right? Before, where you're saying what are the targets for the service that we all agree to. If we all agree, then we know when we hit this, we have to stop doing launches, right? And the fact that it's there, I've only once actually had to declare like a code yellow, this is a problem. Generally speaking, the fact that people know that it's there, it's out there, it's waiting for them, makes them, that's the beauty of it. They will start looking for ways to optimize that, or say, actually we're doing okay, we can just push this and see what happens. If you are looking for ways to get a buy-in to that system in the first place, that's a much longer conversation. I'd be happy to have with you, outside, whenever you'd like.
So I was really interested in this idea of perceived availability as opposed to the actual measured availability of the system.
Yeah.
Do you have any thoughts on how to track or reason about that? Like I was wondering, if the single 60-minute outage actually has a higher perceived effect on availability than 60 one-minute outages, or any other ideas on how you could sort of reason about that?
Sure. So unless you have something, I can talk some more, but
Well, I mean, I can talk briefly about one thing that we thought about, which is this question of is it worse to have 5 10-minute outages versus one 50-minute outage? Because or it's also worse to have, I don't know if you're Netflix, it's worse to have different kinds of outages. Like outages that affect web browsers get more CNN coverage than ones that affect PlayStations. So there's there's actually when we think about availability, we think about what is the public perception of Netflix availability, not necessarily how many 9s are we getting, because public perception drives whether or not people renew their subscriptions much more than whether or not we can say 99 times out of 100 when you tried to stream, you were able to stream without having to try twice. So you're probably fine, right?
And it gets into, you really, if you have these people, they're valuable, they're gold. User experience, anybody like that, even your marketing team, whatever, but the people who actually can go out and survey, or if you have client-side monitoring into an app that you're using or whatever, to get data of what the people are actually seeing and how they react to that. YouTube obsesses over this. Everything's drive more watch time, drive more watch time. And so every little tiny change, we track what happens afterwards to the number of plays that people get and how long they watch them.
So this can be our last
question.
Yeah.
Okay.
This is Ted Takahashi coming from PlayStation. Thank you very much for mentioning that. From my experience, 95 is not acceptable for online multiplayer gaming, so that's for sure. But anyway, thank you for a great talk. So would like to know the notion of this SRE error budget type of thing you discussed with our product team, but how do you go beyond that, like XX, company-wide? Is there any tricks or tips for buying in of the company-wide support for this type of effort?
How do you get company buy-in to this paradigm?
Yeah.
Okay.
Yeah.
Again, like I just told the previous gentleman, that is a really long conversation that I would love to have with you.
Okay.
But I don't think we can do that right here.